So thank you, Camilla, and welcome everybody. For a lot of those I can see here, good evening, and thanks for still listening after so many hours. I'm Werner Krahe, as you said. I'm Director of Product Management at LeanIX, and as part of my responsibility, I worked on the design of the integration API. And that is what I will walk you through in the next about 20 minutes. As you already heard a lot of business-related sessions, this will be fairly different, rather technical. I was thinking about winning the contest about the most technical session, but after looking at the Signavio presentation, maybe a tough race, and I'll see what I can do and maybe add some additional complexity to the presentation. So I will first walk you through the concept of the integration API and how you would integrate with other systems. Keep that rather short, but I will still allow you to follow what I will show you afterwards. The use case I selected may be a little bit special and not necessarily one you initially have thought about solving with the integration API even. I will tour you through this after the introduction. And before I start, second part will be JSON, will be technical, and whenever you may feel rather comfortable focusing on the first part where I explain how the integration API works, you can pick up with that information and may hopefully be already helpful. But let's give it a start. So I will browse you through why we created the integration API and how it works behind the scenes. And that will, as said, help you understanding the demo part later on. The goal designing the integration API was to create an easy-to-use API which allows programmers to fully focus on the system they integrate with LeanIX and not be bothered by the LeanIX data model or entity concepts like fact sheets, relations, things like that. They don't have to learn about all this when creating the connector. Creating the connector should be as simple as sending some data from the other system in a very generic format. It's on our side is the JSON format we call LDIF, LeanIX data interchange format. And all the mapping and processing to the fact sheets, relations, and other things we provide happens behind the API and purely done as configuration. So making data sending as simple and removing all mapping from the connector makes the process sending data to LeanIX the same every time. And that's very important because it already removes or at least reduces the need for logging, auditing, and other concerns you typically have to care about to a very minimum. So, for example, there are no specific parameters when you call the API that would anyhow relate to the processing. And as well, a lot more less issues are to be expected because there are no complex conversions happening on that side. So all is behind the API, and you get all the logging and the alerts behind centrally delivered by the integration API. So the customer can fully focus on creating a decoupled connector. And that holds true, that is important as well to say, not only for creation, but then for further maintenance as well. So if you imagine that at some point you have a change on the data model on our LeanIX side, you don't have to go out to each and every integration and change it there as well. So most of the time this then could be done just via configuration change. So in summary, the integration API provides a very simple REST API with no processing instructions that keeps it simple, reliable. The mapping does not have to be developed for each and every integration. It's fully decoupled. And at the end, we wanted to make it as easy and by that as cheap as possible to scale out the number of systems you may want to connect to our LeanIX. And that is of course one of our plans for the future roadmap of the integration API as well. How do we do this? And answering this question, we get already into how exactly the integration API works behind the scenes. is as easy as every connector just sending us this JSON I mentioned with this data from the other system. The gray box you see here is the JSON format we call LDIF. The orange part inside the gray box represents a data object. How does this map to your data? If you, for example, push some database data to LeanIX, this could be exactly one row of a table. The type would be the table name, the ID would be the unique key, and then having a look at the data section, there you would probably see for each value would represent a value of the table column. And that is what our integration API receives. And to now, as a next step, convert all this incoming data to fact sheets, relations, tags. The administrator will define one or more data processors in our configuration UI. And each data processor is responsible to look at each data object and see if it wants to do something with the incoming data. This is configured in a separate filter. And depending on the type of data processor, the incoming data object can be used for different things. This may be creating or updating a fact sheet. This may be creating a relation or a tag. And the data processors work independent from each other. So multiple processors could even act on the same data object, which means from the same incoming data object you can create a fact sheet and as well create a relation or a tag. We released the first version of the integration API last November, and I presented it here at EA Connect 2019. And over the course of that year, we closely listened to the feedback you had, and we improved the integration API. There were a lot of small things we added, but still a good amount of bigger things we improved in the integration API. And two of these bigger features you see here, I will show you how they work, and I will even show you how they work in combination. The first feature is what we call search-based identification. This feature allows bulk changes on our LeanIX data. So one processor can take the data from an incoming data object and execute a search in our backend that may return 0 or more fact sheets as a result. And all configured changes in the data processor will then be applied to all the fact sheets the result returned. And the search, of course, can be customized on the fly using the incoming data, which makes this solution very flexible. The second feature allows you to merge data from an incoming data object with data we already see on the fact sheet. And this could even include other entities like tags, relations, where you could pick the data from and then use it. We may, for example, only update a fact sheet if some external data, with some external data, if the fact sheet has a specific tag, or if the value of another field matches. Another use case could be we can add to existing values. You can think about cost values you will send via the integration API monthly, weekly, and that will add to the already existing value. What I want to show you in the demo is how to combine these two features. We will use a search for fact sheets, and based on some values, we will tag the found fact sheets with a specific tag. In fact, we will only use the incoming data object as a trigger to initiate the process. In that simple case, in real world, you could add some data at that point as well. So now let's get us to our today's task. What we want to do is we want to read all the applications in our workspace, and based on the values we see on the fact sheets for technical fit and functional fit, we want to apply a time model value, tolerate, invest, migrate, eliminate in our tag group time model. That example is, of course, very simple and far from being usable for any production use case, but as simple as this example currently is, it can be easily extended, of course. So if you think about real value, why not add cost data to the incoming data and then use that as a third criteria to create the time tag from? Or just provide more detailed suitability information on each fact sheet and create a more complex calculation of the tag byte. So at this point, I like to switch to the workspace and go to the live demo. What you see on this workspace is 4 applications. 2 are missing any tagging to the time model, and another 2 currently have some values. They may or may not be the right ones. And what we want to do is we now want to use the integration API to actually change or add these tags according to the data we see inside. And when we look into some of these fact sheets, so for example, the LeanIX self-service portal, what we see here is we have a functional fit that has been filled in and a technical fit that has been filled in. And the same happened for this legacy portal, where we see the functional and the technical fit. And now I move on to the integration API configuration screen. What I want to do is I want to actually execute the integration API part, show you the results, and then go back to the processor and explain you why it worked as expected, as I hope. So let's give it here a try. So I run that configuration, and the integration API service now executes this, processes this data, and what I do is I quickly switch back to the other view, do a refresh of the screen, and what we see is that our application fact sheets are now all being tagged. So we see that the LeanIX self-service portal is marked to be invest, while the legacy portal should be eliminated. And even the other tags we saw before have been changed based on their values on the fact sheet. So maybe that is something to add. The integration API is one of the main principles is that you don't have to worry about the current state of something. So it's really, you define the envisioned target state by what you configure, and that is what the integration API executes on. If you want to have a fact sheet, the fact sheet will be there, no matter if the fact sheet was there before or not. Okay. Good. So we switch back to our configuration, and now I show you in detail why that worked. On the upper right-hand side, you see the most likely smallest LDIF file you could send to our integration API. As we don't need any input data, you see this data object being completely empty. It's still a valid content the integration API can process on. So let's now have a look at the data processor configuration on the left-hand side. When we start, we have to select what type of processor to select. So the inbound tag processor is the one I chose here, because what I wanted to do is I want to create a tag. The next one is maybe already a bit more special. The filter is responsible to check if the processor wants to execute on the incoming data. The integration API does have a special mechanism, so it can count the number of incoming data objects. And here we ensure that this processor only works one time, so only when the first data object was sent. So no matter how many data objects arrive, this processor will only do the work one time. The next part is the identifier part. Here we define the target fact sheets we want to operate on. And in this case, it is a search. So as explained, we can use this search, and all the processor operations will then be executed on the fact sheets that the search returned. And in this case, it was the 4 applications. We could add a lot more restrictions here. So basically everything you see and are able to filter in the UI, you can do here as well. The next part is the read section. What may this be about? So for each identified fact sheet, we can read defined content and make this content available in the processor. This could be all kinds of data. So it can be assigned tags, it can be relations. In this case, it's very simple. We only ask for the current value of 2 fields on these fact sheets. And that is the values for functional and technical suitability. Getting to the last part, the update section. And that section holds all the configuration we want to do on the target object that have been identified. And that's, in this example, the largest one. So what we do here is we define all the different target keys, all the areas we want to write to. In this case, we want to write to a tag group with a name time model. And we want to write a tag name. And with a tag name, I get to the values section here. When configuring values in the integration API, the input may be static, may come from the ELDIF, from the data object. It may come from what we defined in the read section. We will see that. Or it may come from variables. Can even be a combination of all of them. Variables are a rather advanced topic. I don't want to touch here. So they can be used to actually pass information even from one to the other processors, most likely used then for aggregation use cases, or want to count something on the incoming information. So this value section here offers 5 different options. And if not specified differently, the value section operates in a mode we call select first. So this means that we have all these configured options, and they will be tried in order. And the first option that returns a valid result will win and will be written. So for example, the line 1 here, you see that, will check for the functional suitability and unreasonable, or the functional suitability is insufficient, and at the same time it needs to be the technical suitability inappropriate or unreasonable, and then we will set a tag named eliminate. We'll have the other options configured as well, and if data is missing, we will tell that by setting the specific tag in that simple example. And that is already everything you need to do and to get to the simple example use case I just showed you on the workspace. So what did we learn from this example? In order to change a value on the LeanIX side, it may not always be needed to export the data, to process it, and write it back in. So you may consider instead doing that on the fly while writing to the integration API. That was one use case that covers the new functionality. I hope that the presentation gives you some inspiration how you could use the API a little bit different. There's of course a lot more you could do. So if you're interested, you can consult our documentation, or you can all the time give us a call, and we will be there for you and listen to your use case, and we'll help you to get the use case solved. Yeah, I think we don't have that much time anymore. So I'm at the end here. I'd like to again thank you for listening that late with this rather technical session. Hope you enjoyed it a bit. And Thank you.
A round of applause to Werner Krahe.